So, welcome back to my channel. As you might have noticed, I haven't uploaded anything for many years, right?
Yes.
And in one of my last videos, Vida was just very, very small, like this big. And now he's obviously grown up and he's actually old enough to be in my videos.
Yeah, for once.
Yes. And for this video, he's going to help me filming and he's going to be the cameraman, right?
No, camera boy.
The camera boy, yes.
Yes.
That's right. He's going to be the camera boy. Okay, so I'd like to give you a tour of my big lathe, a TLV machine that I bought. This was my first big machine for my machine shop. When I bought it, I didn't know much about machining or this types of machines, but this one came up for sale, so I bought it for a good price. I was lucky, I got a lot of good accessories with it, but when I bought it, I didn't even know what brand it was. It turned out it was a TLV from Ture Lindverkstäder in Vimmerby, Sweden. And I don't know much about him, or the only thing I've heard is he made these machines and he made some mills also, and that he eventually died in a plane crash. Many years ago I stopped by a machine dealership and they had a lot of papers about TLV lathes, so since I had one, they were kind enough to give the papers to me, and I've had them scanned and sent the copies to Tony at the lathe.co.uk website. So everything I have is at his website. No model of lathe in the paperwork I came across depicts exactly a lathe like mine, but this one is pretty similar. It's called the Type 235B and the 255B. Here's also one that shares a lot of stuff with my lathe. This is called the 210S. Another one that is pretty common is the TLV 250 and 305 lathes. I've come across these for sale a couple of times here in Sweden on different ads. Here's another picture of that one, and also a picture of one called the OE235. And as I said, all the documentation I came across have been scanned and sent to Tony at lathe.co.uk for you to have a closer look at, if you so wish. A couple of years ago, Lathe was here, and we thought there was some problems in the carriage of this machine. So we took it apart, and when we did so, we filmed it. So I have some footage. It's a couple of years old now, but I'll just edit in here so you can have a look at it. Hello, today I'm here with Laurits Sakstrup, who's also in YouTube. He has his own channel but hasn't uploaded much so far. And we decided to disassemble my lathe because I thought I had a problem in the compound, but we've taken it apart and cleaned it, and we found that there was actually nothing broken. So now we're just going to put it back together, and I thought I'd show you how it works inside here.
This part engages and disengages the lead screw with the movement of a lever here. And the next lever moves these two gears to engage the cross feed. This is lower position, this is neutral, and this is engaged. The last position isn't useful, but it's still there. Anyway, this gear gets turned by the hand wheel. And the thing we were unaware of was that there's a friction clutch for the longitudinal feed, and on the back side that we can show later, there is a knurled knob that you tighten in order to let's see here. Okay, it's rubbing against the table, but still, I think you can see that it's compressed here, and I loosen it and it disengages. There's two plungers that disengage the gear, and we were unaware of this. But still, taking it apart was a good thing because it was very dirty, and we spent almost the whole day cleaning it. I neglected to mention a few components and a safety feature. There's a rod underneath here, and there's a groove that will block the feed, longitudinal and cross feed, if you're able to engage the threading nut. And you can, depending on how you move this arm, you have either feed in one direction or in the other. And I'll start taking the different components apart. Let's see. And perhaps you can see it a little bit better here. And this, I'll take this out as well. You can move it and it engages the gears. And it turns in the opposite direction. And underneath here is, okay, there's a tooth here that is for the transmission of the different components. And underneath here, we have the friction ring, and these are to disengage the feed when you undo the nut. We've taken everything apart, and I'll talk about each component as I put it back together again. This is the friction clutch, and this angled part contacts this inside. And there's two brass pins that push against the backside to disengage the feed when you undo the nut. So this goes back on here, and there's a rod with a tooth that on the other side this nut screws, and that presses against this to push it in. So I'll put it back together again. Let's see. Underneath here, there's a safety feature depending on where you position this. There's a groove that enables you to close the threading nut when it's in the right position, and this will also actuate the position of the gears, and that in turn changes the direction of the feed. So we put it back together again here. So this lever is to close the half nut. Let's see. Okay, and it's fully open in this position and fully engaged here. And this lever moves, and that's the neutral position, and that's just additional room. And when you move it up here, then it's engaged, and you can feel it index in two different positions. So this is neutral. And here's the friction clutch. This shaft is connected on the backside with a small tooth, and in order to enable movement. And the shaft it goes through is slightly higher, proud from this surface. So when you put the friction nut on, I'll screw it on, you can tighten it up and make everything move without it binding on the static metal. So on the back side it's engaged now, and that makes this wheel move. So if we disengage it, let's see, without pinching my fingers. So, okay, so I'll move the gears and you can see the axis moving, but this gear won't move. But I tighten it again and you get the full movement. Unfortunately, we were unaware of this clutch, and we never tightened this enough, so we had to take it apart to find out, and fortunately we had a good reason to clean it.
Okay, so this is the carriage, and it has a big crank here for moving the carriage back and forth, of course. And then it has a lever here where you can switch from thread cutting, which is in the middle position, and through front and back feed. For the lengthwise feed, it has a clutch mechanism that's engaged by turning this knurled knob to the right, and is released by turning the knurled knob to the left. If you want to engage the cross slide, it's this lever. And if you want to start cutting threads, you engage this lever. This lathe has spindle speeds from 18 RPMs to 1000 RPMs. And there's a gearbox here in the headstock where you can choose between a high, that is between 180 to 1000 RPMs, and a low, which is 180 to 140 RPMs. And you choose by engaging this lever. And then it has a gearbox down here, which is operated with these two levers. And here you have the table of the different spindle speeds, and of course these two are the levers down below, and from 18 to 140 that would be in the low gear, and then from 180 to 1000 RPMs that would be in the high gear. If I undo the 4 screws here that keep the cover in place, I can remove the cover and show you what goes on inside the headstock. Here you have 3 belts coming up from the 6-speed gearbox down below, and they transfer the force that goes in here, and you have a mechanism that slides these parts back and forth in order to engage the high or low gear. There's also a gear here that goes down to another gear that goes out to the left of the machine, and this drives the carriage feed mechanism. This lathe can cut threads in both imperial and metric pitches. And in order to help you to set the machine up, there's a table here that tells you how to do it. And it can cut from 7 millimeters to 1 millimeter per thread in metric pitches, and in imperial pitches you can have from 2 to 56 threads per inch. When you set it up, you first have to put the right gears in here, and you open here and you change 2 of the gears in the mechanism here. And after that you choose, according to this table, a lever in position A, B or C, which is this one, and then you put this one in a position from 1 to 7, and then it cuts the threads for you when you engage the thread cutting mechanism. If you engage the lengthwise feed, it will feed at a rate of 1/10 of what you set on your thread cutting pitches. When I open the cover at the left hand side of the machine, I find the gears that allow me to change the feed ratio of the lathe. And the gears that affect the feed ratio are this wheel and this wheel. The one in between is just used to transfer the force, because this will always be 1 tooth to 1 tooth, no matter the size of this one. However, this one has to be moved around since the sizes of these are different when I change the feed ratio. And in order to move this wheel, I can loosen this bolt, which allows me to swing the mechanism in and out like so. And I can also undo a nut here, which allows me to move these up and down. So essentially, when I want to choose a new feed ratio, I check the table, I find out the size of this one, I find out the size of this one, then I move this one up until it engages, then I tighten the nut here, then I swing it into place here until it engages here, then I tighten this bolt, and I'm set to go. There's an additional mechanism here that allows everything to go backwards. Of course, this is the one I use if I want to cut left-hand threads. So then I just loosen this one and switch like so, and I get an additional wheel into the gear train, and I will be able to cut left-hand threads. This lathe has a threaded spindle nose. So this is what the spindle nose looks like, and since the forejaw I got with the lathe is very big and of course heavy, I wanted to have a smaller forejaw. And I bought one, but I didn't have a backing plate for it, so of course I had to make a backing plate, and then I would have to turn it so it would fit the spindle nose. But how do I turn it to fit the spindle nose when I can't use the spindle nose as a gauge, because of course the spindle nose is in the lathe when I'm making the backing plate? Well, my solution that I came up with was to make a dummy of the spindle nose. So I made this dummy using one of the backing plates as a gauge, and then I could use this dummy spindle nose as a gauge when I made the backing plate for the forejaw. I was lucky enough to get the TLV lathe with a lot of accessories, and this chuck is the one that was on the lathe when I bought it, and this had all three outer jaws for it. As you can see, I have the steady rest and I have the moving rest that is screwed onto the carriage. I got a big forejaw. This is of course very big and nice, but it's also very heavy, so since I don't have a crane here, at least not yet, it's very difficult to put it on this spindle nose. So I bought a smaller forejaw and made a backing plate for it, and I've used this a couple of times. I also got this, which is for turning between centers, where you put this on the spindle nose, put this inside the spindle, and then you have a special driving thing that is screwed onto the workpiece, and that's turned around by this crank here. I also got this big and nice plate where you can use T-nuts to screw things onto this. Apart from what came with the lathe, I also wanted a chuck with removable top jaws, because I wanted to be able to make and use my own soft jaws, which I've shown in the previous video. So this is the one I bought with the removable top jaws, and there was actually an extra backing plate that came with the lathe that I used for this purpose. As you might have noticed, there's a small foot pedal on the floor, and actually this is a safety mechanism. A lathe like this is a very powerful machine, and if you're caught in the chuck and it pulls you in, you have a high risk of getting seriously injured or even die. So I put this pedal here, so the lathe will only run when I press the pedal, because I figure if I'm caught in the chuck, I will start kicking and screaming, and I will lose the pressure on the pedal and the lathe will stop. Of course, you don't always want to have this mechanism on, because sometimes you just want the lathe to keep running. So I can easily disengage it by opening here and flipping a switch down here, and it will work just like a normal lathe. I've installed an additional safety feature here. This is simply a ring, and here's a long screw that prevents me from putting the lathe in reverse. Since the lathe has a threaded spindle nose, if it's in a high gear and I put it in reverse, the chuck might get unscrewed and come flying off the lathe. So Usually I don't want that to happen, so I just keep this screw here. Sometimes I want to actually be able to put the lathe in reverse, such as when I'm cutting threads. And when I want to do that, I simply just do like this. Move the screw out of the way, and I can put the lathe in reverse normally. This tool post is called the Malkus tool fix, and this is the medium size that's called 3 to 4. There's also a smaller one that's called 1 to 2 and a bigger one that's called 5 to 6. You remove the tool holder by loosening this screw and just lifting it up. As you can see here, it has 2 screws for adjusting the height of the tool and 3 screws for securing the tool bit to the tool holder. When you put it back, you just drop it into place and secure it by tightening the screw here. When I bought the lathe, it only came with 1 or 2 of these, and I bought a lot more, so I have tools set up with the right inserts and everything, as you can see on the wall here. If you want to do boring, you can put small boring bars in a regular tool holder like this, but if you want to use bigger boring bars, you can use special boring bar holders that are made for the Malkus system. And here is one, as you can see, with a round hole in it. And if you put this on the tool post, like so, tighten it, and you can just move it around, and you can start boring like this. I even have a bigger one that's for even thicker boring bars. Here, I'll put this on, a real heavy and thick one that takes a ground carbide bit, like so. Okay, I hope you enjoyed this tour of my TLV lathe, and me and Vida, we had a lot of fun making this video.
Yes.
And if you like videos like this about machining, don't subscribe to my channel. I barely know what I'm doing, and besides, I don't upload a lot of content. Instead, I recommend you subscribe to Cutting Edge Engineering. That's an Australian guy who's really awesome, and he really knows what he's talking about, and he has a lot of awesome content. If you want to see more of Vida, he also has his own YouTube channel.
Or not my own, it's me and 2 of my friends. We have a joint YouTube channel. If you want to check that out, here is the channel.
Yes, it's called the HVM channel. I'll put the link in the description below. Okay, bye bye.